All right, here we're back for more rates of change, your first lesson for Unit 2. I'm calling this topic 2.0 because the definition of a derivative, I thought was going to start out with that. And I decided let's do this first because it connects Unit 1 to Unit 2. So this is like 2.0 before we learn about the definition of a derivative. So rates of change, which we talked about really quickly in Unit 1, we talked about it as the slope of a line, right? The average of rate of change over time. You can find the instant rate of change if you narrowed the interval and made it smaller and smaller, right? So now we're going to relate that to velocity. The function s that gives the position of an object as a function of time t is called the position function. If the object changes position over time, the average velocity is given by the formula, right? So if we're finding velocity, it's position divided by time. So you can say it's the change in position, so the delta position over delta time, which means you could also just say it's the change in s over the change in t, because they told us that s is the position function, so delta s over delta t. Concept, and then using the variables they gave us. So let's work with that. Let's find rates of change as it relates to velocity. So first example, a tennis ball is dropped from a height of 100 feet. Its height s at time t is given by the position function there. S equals negative 16t squared plus 100, where s is measured in feet and t is measured in seconds. Find the average velocity. So average velocity over that time interval means the slope over that time interval. So average velocity, we have two different intervals here. Average velocity equals the slope, right? So what is the slope? It's going to be the distance at 2 seconds minus the distance at 1 second, the beginning of the interval, over 2 minus 1. Right? Delta y over delta x, same slope. So how do I find s of 2? Well, we're going to plug it into your calculator. And I didn't bring mine, so I'm just going to write it over here. So 2 squared plus 100 ends up being 36, and s of 1 ends up being 84. And you can put that in your calculator if you don't trust me, okay? So that comes out to 36 minus 84 over 1, which ends up becoming negative 48. What does negative 48 mean? It means negative 48 feet per second. So that means the average velocity over that time interval, the speed is decreasing at an average rate of 48 feet per second, this tennis ball. Okay, what happens if we narrow the window to, or the interval to 1 and 1.5? Now the average velocity equals s of 1.5 minus s of 1 over 1.5 minus 1. S of 1.5 ends up coming out to be 64. S of 1 we already figured is 84. We're going to figure that out. Over 0.5. And that whole thing comes out to negative 40 feet per second. If you put that in your calculator, negative 40 feet per second. So when we narrow the window, the average velocity gets a little bit slower, right? It's decreasing at a slower rate. But either way, both velocities are negative. So this indicates that the ball is moving downward, right? The ball is being dropped. So it's going down. And it's, depending on your interval, somewhere between 40 and 40 feet per second. Okay, so all we're doing is connecting this idea of velocity to slope and to rates of change. So you can see that we've decreased the interval here. We went from 1 to 2 to 1 to 1.5. As we decrease this interval, we can find what's called the instantaneous velocity. Okay, so what is the velocity at an instant? In other words, this velocity function is what we're calling the derivative. Okay, it's the derivative of a position function. Derivative. So we're going to talk about the formal definition of a derivative in the next lesson, but what you need to know is that velocity is a derivative of the position function. Why? Because it gives you the instant rate of change of the position function. So the instant ROC of position function. So velocity is a vector, which means it has direction. So velocity can be positive, negative, or zero. And remember, speed, when you talk about speed, it's the absolute value of velocity, right? So how fast something's changing. So what this means is if you have, let's say this is your distance, right? So we'll call it S of t, and this is your time. And let's say you have some function like this, right? Something that's speeding up, maxes out at 0, and comes back down, right? Doesn't even matter if it's 0. If you're finding, if this is your position function, if you're finding the velocity, if you can narrow that interval and make it smaller and smaller, you can find the velocity in an instant. So what does that mean? If I wanted this instant, I would have to narrow my interval to be super close to that pink dot, and I would be able to find the velocity by finding the slope of that tangent line. So the velocity equals the slope at an instant, which equals the slope of the tangent line at that point. And all of this is what we call the derivative. Okay, so let's do some examples. Here's the first example. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above water. The position of the diver is given by s equals negative 16t squared plus 16t plus 32, where s is measured in feet and t is in seconds. When does the diver hit the water? What is the diver's velocity? What is their speed at impact? And when does the diver stop moving upward and start their descent? So there's this diver jumping from a platform diving board. Part A asks us to find when the diver hits the water. So the diver is going to hit the water when what? So S, a diver jumps from a platform that is 32 feet above water. The position of the diver is given by this. So this function. So S has to be 0 when he hits the water. He or she hits the water, right? Because the distance is, the max distance that they could be is 32 feet above water, and then at 0 they hit the water, right? Because you can imagine the person jumps off a diving board and it's like that, right? So this is when we can say S is 32, and down here at the water we're saying S is 0. So let's figure that out. Let's set this whole thing to 0. 0 equals negative 16t squared plus 16t plus 32. All right, now hopefully you're seeing you can factor this, right? You can take a 4 out first if you want. So you could say it's this. Right? Now I'm noticing I can actually take out, I could have actually taken out 16, so let's do that. Let's take out minus 16, so then we have t squared minus t minus 2. Now hopefully you can see that you can factor that to t minus 2 and t plus 1. Right? So that means t equals 2 if I'm solving for t, or t equals minus 1. This one doesn't make sense. We're talking about time. We can't have negative time. So right now, the only solution I have is that t equals 2. So the diver hits the water when t equals 2, what is it? Is it seconds? Yes, so we're saying 2 seconds. So there's my answer for A. What does B say? B says, what is the diver's velocity at impact? What is their speed? So velocity is the rate of change over a time interval, right? So here's what we're going to do. We're going to say that we need to find